So now let's look at recurring decimals. So recurring decimals are decimals in which one or more digits repeat infinitively. So it's ongoing. For instance, 0.3 recurring, that dot there essentially means that it's 0.333333, and it goes on pretty much forever. So let's look at this question here, which says write 0.72 recurring as a fraction. So what we do here is we label 0.72 as x. So let x equal to 0.72727272 ... And then we find out what 10x is. Remember, whenever we times by a multiple of 10, we move the decimal place to the right. Because we are timesing by 10, we move it once to the right. So we get an answer of 7.27272727. Okay, essentially what we are trying to do is essentially try to subtract the numbers from each other and get rid of the sort of decimal point, so the numbers after the decimal point. So if we look at x and 10x, we can see that if we subtract x from 10x, we're not eliminating the numbers that are next to the decimal point, are we? So let's look at 100x. So if we times 0.72 recurring by 100, we get 72.727272. So now we can see that the 100x, and the x next to the decimal point, so the 727272 and the 727272 for x and 100x match. So when we subtract them away from each other, we can eliminate the numbers that are to the right of the decimal point. So if we do 100x, subtract x, same thing as saying 72.7272 and 0.7272. If we subtract that, this side we get a 72. 100x take away 1x is 99x. So if we want to make x the subject here, essentially what we need to do is divide by 99. So x is equal to 72 over 99. Now, as this question doesn't tell us to simplify, we can leave it as it is. But if the question said that we must simplify to its fullest, then if we can see, both of these numbers here are both divisible by 9. So if we divide 72 by 9, we get 8. And if we divide 99 by 9, we get 11. Okay, let's do this one right here. So prove algebraically that 0.58 recurring is equal to this. So as we normally do, so our x is going to be, I should say, let x be 0.58888888. 10x would then be 5.888888. But does that match? No. So let's work out what 100x is going to be, which is going to be 58.888888. Essentially all I've done is move the decimal place once to the right each time. So we can see that the 10x and the x match. So if we subtract them if we subtract them away from each other, then we can get rid of these 8's at the end. So we do 100x subtract 10x. So 58.8888. And then 5.888. The 8 will cancel out. So essentially we're doing 58 subtract 5, which is 53. And then 100x subtract 10x is 90x. So 90x is equal to 53. So work out what x is, we divide by 90. So we get x is equal to 53 over 90. Lovely.